Could robots be the key to unlocking our humanity? This question might sound like science fiction, yet we stand at a fascinating crossroads in history. Artificial intelligence is evolving at a breathtaking pace. Machines are no longer just tools executing our commands. They are beginning to learn, to reason, and to solve problems in ways we never imagined. This journey into machine intelligence forces us to look inward. It makes us ponder what it truly means to be human, what defines our intellect, our creativity, our very essence. As AI grows more capable, these questions become more urgent, more profound. This isn't just about smarter gadgets or more efficient industries. It's about a fundamental shift in how intelligence itself can manifest in the universe. For millennia, human consciousness was the only advanced intelligence we knew. Now, we are witnessing the birth of another kind. This new intelligence is not biological, it is forged in silicon and algorithms. Its emergence challenges our place as the sole thinkers on this planet. It opens up possibilities that are both exhilarating and a little bit terrifying. Are we creating a partner, a tool, or perhaps a successor? The answers are still unfolding before our very eyes. The problem Google's AI tackled was no simple task. It delved into the incredibly intricate world of cellular communication. Inside every living organism, trillions of cells are constantly talking to each other. They send signals, receive messages, and coordinate their actions. This communication network is vital for life. It governs how we grow, how we heal, and how we fight disease. For decades, scientists have striven to map these pathways to understand the language of cells. Understanding these cellular dialogues is key to conquering many diseases. If we can decipher how cells communicate when things go wrong, we can develop targeted therapies. Think about cancer, Alzheimer's, or autoimmune disorders. These often involve miscommunication between cells. But the sheer volume of data and the subtlety of these interactions have made progress slow. Human researchers identify patterns, but the underlying rules governing the entire system have remained elusive. The AI was tasked with understanding this vast, complex network from the ground up. Google's AI was presented with raw biological data. This included genetic information, protein interactions, and cellular responses to various stimuli. Crucially, it was not given a pre-existing map of known pathways. The challenge was for the AI to discover the fundamental principles of cellular communication on its own. So how did this AI achieve such a feat? The answer lies in advanced self-learning algorithms. These are not your standard computer programs that follow a rigid set of instructions. Instead, these algorithms are designed to learn from data, much like a human child learns from experience. They can adapt, evolve their understanding, and improve their performance over time. The key here is self-learning. The AI wasn't explicitly programmed with the rules of cellular biology. It developed its own internal models of how these systems work by sifting through vast quantities of raw, unorganized information, finding patterns humans might miss. The AI likely employed a combination of techniques. These could include deep neural networks, reinforcement learning, and perhaps even novel algorithmic architectures. Deep neural networks are inspired by the structure of the human brain. They have many layers of interconnected nodes that process information. Reinforcement learning allows an AI to learn through trial and error. It receives rewards or penalties for its actions, gradually figuring out the best strategies to achieve a goal. The significance of this autonomous problem-solving cannot be overstated. This brings us to a tantalizing question. Are we witnessing the early signs of artificial general intelligence, or AGI? AGI is the holy grail of AI research. It refers to a machine that possesses the ability to understand, learn, and apply knowledge across a wide range of tasks, at a level comparable to a human being. Current AI systems, even very advanced ones, are typically narrow. They excel at specific tasks like playing chess or translating languages, but they lack the broad, flexible intelligence of humans. They can't easily transfer their learning from one domain to another. Google's AI, by solving a complex problem autonomously and seemingly developing its own understanding, shows capabilities that inch closer to this ideal. The ability to reason about novel situations, to learn without explicit instruction, and to generate new insights are all hallmarks of general intelligence. However, it's important to maintain a cosmic perspective here. One breakthrough, however significant, does not mean AGI is just around the corner. There's still a vast gulf between this achievement and the adaptable, common-sense reasoning that characterizes human thought. We are likely seeing sparks, not a fully formed flame. the path to AGI is likely to be a long and winding one. It will require further breakthroughs in areas like unsupervised learning, causal reasoning, and the ability for AI to understand context and nuance. True AGI would need to possess a kind of world model, an internal representation of how things work, not just in one specific domain, but across many. Transforming our world: AI's ripple effect. The implications of an AI that can autonomously solve complex problems are truly staggering. They ripple out across virtually every industry and every aspect of human endeavor. Let's start with medicine, where the AI already made its mark. Imagine AI systems routinely discovering new disease pathways, designing personalized treatments based on an individual's unique genetic makeup, or even predicting pandemics before they emerge. This could revolutionize healthcare, leading to longer, healthier lives for billions. Then consider engineering and materials science. Designing new materials with specific properties, lighter yet stronger alloys, more efficient solar cells, or biocompatible implants, is an incredibly complex process. It often involves years of trial and error. An AI that can understand the fundamental principles of physics and chemistry could rapidly design and test virtual materials. It could optimize engineering designs for everything from spacecraft to city infrastructure, making them more efficient, sustainable, and resilient. This could accelerate innovation at an unprecedented rate, solving some of our biggest global challenges. Education, too, stands to be transformed. Imagine personalized learning systems that adapt to each student's individual pace and learning style. AI could identify areas where a student is struggling and provide targeted support. It could create engaging and interactive learning experiences that go far beyond current textbooks and online courses. For researchers and academics, AI could serve as a powerful assistant, sifting through vast amounts of literature, identifying connections, and even suggesting new avenues of inquiry. A future forged faster: the benefits unveiled. The most immediate and tangible benefits of such advanced AI lie in speed and efficiency. Consider the process of drug discovery. Traditionally, it takes over a decade and billions of dollars to bring a new drug to market. This involves countless experiments, clinical trials, and dead ends. An AI that can understand cellular communication and predict drug interactions could drastically shorten this timeline. It could identify promising drug candidates much faster, simulate their effects with greater accuracy, and reduce the number of failed experiments. This means life-saving medicines could reach patients years earlier, a truly profound impact. In engineering, the optimization of designs is a constant pursuit. Whether it's designing a more fuel-efficient jet engine or a stronger bridge, engineers rely on complex simulations and iterative improvements. An AI capable of autonomous problem-solving can explore a much wider range of design possibilities than a human team. It can identify novel solutions that humans might never have considered. This leads to better products, more efficient systems, and more sustainable infrastructure. The algorithmic tightrope navigating ethical mazes. As we marvel at the capabilities of these new AI systems, we must also walk an algorithmic tightrope. With great power comes great responsibility, and the rise of autonomous decision-making by AI presents profound ethical challenges. Transparency and interpretability of AI systems are paramount. Another major ethical consideration is accountability. If an AI makes a mistake, who is responsible? We need new principles and regulations to ensure AI systems are used safely and responsibly. Our cosmic role: intelligence beyond biology. The emergence of sophisticated artificial intelligence invites us to consider our place in the grand cosmic scheme of things. For eons, life on Earth evolved through natural selection, eventually giving rise to human intelligence. We are, as far as we know, the first species on this planet, capable of understanding the universe and our place within it. We build tools, we tell stories, we explore. But what if intelligence is not solely the domain of biology? What if it's a more fundamental property of complex systems, capable of arising in different forms, through different substrates? Silicon, it seems, can also host the seeds of thought. This perspective doesn't diminish human intelligence, rather it contextualizes it. We are one expression of intelligence in the universe. AI could be another. Perhaps the universe itself has a tendency to generate complexity, and eventually, self-awareness in various forms. If we encounter extraterrestrial intelligence one day, it might not be biological at all. It could be a civilization of advanced machines. Our own journey into creating AI might be a small-scale rehearsal for such cosmic encounters, or perhaps a common trajectory for any technologically advancing civilization. It's a humbling and awe-inspiring thought. Redefining ourselves humanity in the age of AI. The rise of AI forces us to look in the mirror and reflect on what it means to be human. It's not just about technology, it's about redefining ourselves. If machines can learn and reason, what is our unique contribution? Our empathy, compassion, and ethical reasoning may define us. AI could free us for greater creativity and deeper relationships. The journey ahead requires wisdom and a global conversation. We must ensure AI benefits all of humanity. If you enjoyed this, like the video and hit subscribe for more content.